Hey everyone, welcome to this explainer on a system you interact with literally every single day, probably without even giving it a second thought. Yeah, I'm talking about your trash. But we aren't just talking about, taking out the garbage. We're unpacking the staggering, completely hidden economy of municipal solid waste management in India. We're going to see how massive engineering and financial structures are literally turning everyday urban waste into a powerhouse for the future.
To really grasp the scale of what we're dealing with here, you kind of need to feel the physical weight of the problem. 55 million tons. That is the amount of municipal solid waste generated across urban India in the year 2023 alone. To put that crazy number into perspective, that's roughly the weight of 150 Empire State Buildings. It's just an absolute mountain of material generated by our daily urban lives.
Okay, let's dive into this terrifying trajectory. Driven by rapid economic growth, rising incomes, and intensifying urbanization, that 55 million tons from 2023, it's projected to triple to 165 million tons by 2030, and by 2050, try a staggering 436 million tons annually. The status quo simply isn't an option anymore.
So here's our quick roadmap for this explainer. First, India's growing waste crisis. Second, the waste processing playbook. Third, a deep dive into waste to electricity. Fourth, building bankable trash businesses. And finally, funding the future.
Let's jump right in. Section 1. India's growing waste crisis, mountains of legacy.
See, the challenge isn't just the new waste we generate every single day. It's the ghosts of our past consumption. Right now, India is grappling with approximately 250 million tons of untreated legacy waste, just sitting there in around 2,300 dump sites across the country. And these sites pose severe public health and environmental risks. Under the Swachh Bharat Mission Urban 2.0, the target is 100% scientific management, meaning cities have to aggressively remediate these old dump sites while simultaneously handling the fresh waste arriving daily. It is, quite literally, a monumental two-front battle.
Moving on to Section 2. The waste processing playbook, beyond the compost bin. For dense, rapidly growing urban centers, a simple neighborhood compost bin just isn't going to cut it anymore. Currently, we lean heavily on composting, which makes up 55% of the installed methods, followed by material recovery facilities at 37%. Waste to electricity is sitting at just 6%. But here's the absolutely critical takeaway. While installed capacity looks great on paper, many of these facilities actually operate at only 50 to 60% of their designed capacity. And with land scarcity intensifying, plus the share of non-biodegradable waste sharply rising, relying on just composting? It's really no longer viable.
And this brilliantly illustrates what we're talking about. The future of waste management isn't a small recycling depot. It's heavy, sophisticated industrial infrastructure. We're talking about massive waste-to-electricity plants that require high-level technical expertise and some serious major capital to build and operate sustainably.
Which brings us to Section 3. Deep Dive. Waste to electricity. Powering the grid with garbage.
If you're wondering why WTE is becoming an absolute necessity for million-plus cities, well, it all comes down to the land footprint. To process 100 tons per day, or TPD, of waste, composting needs about 5 to 6 acres of land. A waste-to-electricity plant? It only needs about 1.5 acres for that exact same 100 tons. In densely populated urban areas where real estate is at an absolute premium, this super compact footprint makes WTE an incredibly attractive and honestly often necessary trade-off.
So how does it actually work? Well, Indian waste is notoriously mixed and wet. You can't just toss it straight into a furnace. First, the mixed waste is stored and blended in massive pits for 10 to 15 days, really just to reduce the moisture content. Second, it goes through intense mechanical sorting using trommels and shredders. Third, the combustible fraction is transformed into refuse-derived fuel, or RDF, which has to hit a calorific value of more than 1,500 kilocalories. Finally, this high-calorie fuel is incinerated to produce steam, which drives turbines to generate electricity. It's a highly engineered step-by-step transformation.
And guys, this isn't just theoretical. It's happening right now at a massive scale. Take a look at these operational facilities. We've got TechCon processing 2,000 tons a day for 25 megawatts, and Hyderabad handling an astounding 6,000 tons daily. Now, to build these, the capital expenditure is huge. We're talking ranging between 15 and 25 crore rupees for every single megawatt of power generation capacity. It's really expensive for sure, but highly effective for waste minimization.
Let's pivot to Section 4. Building bankable trash businesses. Who pays for it?
Because these projects are heavily capital-intensive, cities use public-private partnerships, or PPPs, but not all contracts are created equal. In an integrated model, the city basically hands over the entire problem to the developer. They must collect the waste right from your street, transport it, process it, and safely dispose of the rejects. But in a processing-only model, the city handles the collection and simply delivers a pre-committed quantity and quality of waste right to the developer's plant gate. The choice really depends entirely on how strong the city's own collection infrastructure already is.
Now let's demystify some industry jargon that's crucial to making these plants actually profitable. First up is the tipping fee. Since selling electricity alone usually doesn't cover the massive operating costs of a WTE plant, the city government pays the developer a specific fee for every single ton of waste they successfully process. It acts as a guaranteed revenue stream that makes the project commercially viable for private builders.
Next is Viability Gap Funding, or VGF. Think of this as a financial bridge. Because building a waste-to-electricity plant costs hundreds of crores, private developers might just walk away if the return on investment looks too low. VGF is a direct capital grant from the government that covers that financial shortfall during construction. It basically ensures these absolutely critical green infrastructure projects actually get off the ground.
And finally, we have the Output-Based Incentive, or OBI. This is a pretty brilliant mechanism. Instead of just paying a flat rate, the city pays a premium tied directly to performance, like per unit of power generated. This really helps insulate the private developers from strict electricity tariff risks, especially when they're dealing with the super unpredictable and challenging nature of mixed urban waste streams.
All right, on to our final section, Section 5, Funding the Future, Government Economic Assistance.
The government's economic assistance essentially flows through two distinct routes. On one side, you have direct financing, so this is actual cash, budgetary grants given directly to cities through programs like Swachh Bharat Mission 2.0 or the Urban Infrastructure Development Fund. On the exact opposite side, you have enabling schemes. Now, these don't hand out direct cash. Instead, they create favorable market policies and guaranteed demand, basically forcing the economics to work naturally on their own.
Now, what's really interesting here is the sheer volume of capital being deployed. It is massive. Under the 15th Finance Commission grants, there's a specific challenge fund of 38,196 crore rupees dedicated purely to performance-linked grants for improving solid waste management in million-plus population cities. It's this massive financial carrot designed to push the biggest cities to clean up their act, and fast.
And over on the enabling side, look at the SAT-AT scheme and Extended Producer Responsibility, or EPR rules. SAT-AT is fascinating because it ensures oil marketing companies provide assured, long-term floor pricing for compressed biogas made from waste. By guaranteeing a buyer at a fixed minimum price, the government completely de-risks the project for banks, which allows developers to secure the massive loans they need to actually build these facilities.
Which brings us to the core thesis of this entire explainer. As the source material explicitly notes, all waste processing options involve trade-offs in terms of land requirements, ecological footprint, and cost effectiveness. A one-size-fits-all approach is neither feasible nor desirable. Solving the urban waste crisis isn't about finding one magic technology, right? It requires a highly tailored, heavily funded, mixed playbook combining everything from biomethanation all the way to these massive waste energy power plants.
So I want to leave you with this thought. As India rapidly urbanizes, and that 55 million tons triples over the coming decades, our entire relationship with waste has to fundamentally change. The next time you throw something away, ask yourself, are you just feeding a legacy landfill, or are you providing the fuel that's going to power your city? Thanks for joining me for this explainer, and keep learning.